All right, today is day 6. We're going to talk about what's called standard deviation. Yesterday we talked about some measures of central tendency. Today, standard deviation is one of the main measures of dispersion. So our learning targets here, I can analyze data by calculating measures of spread, and I understand standard deviation is a measure of how far the numbers in a data set deviate mean, so how far it's spread out. So yesterday, I didn't really talk about this much. Yesterday we talked about range, I believe. And range was the biggest number minus the smallest number. Well, I should have put that in there about range. But another and much more famous is standard deviation. To find the standard deviation can be very time consuming by hand. So we're going to have you do that for a little bit here. We're going to do one time all the way through. We're going to do it by hand just so you see what's going on. But the big idea is that standard deviation is how far on average each data set is from the mean, how far away it is. So to find standard deviation, first off, we need to find what's called variance. So there's a formula for variance. Once you have variance, you square root variance to find standard deviation. Okay, so here's some step-by-steps on what to do. And there's lots of symbols here. So I put over here a little legend so we can remember what they are. So the mean, we say x bar. That's a little bar above it. So that's the mean of the data. So first we need to find the mean. So at the very first step of finding standard deviation is finding what the mean is. So find the mean, then find the difference between each value in the data set and the mean. So we have to find all the differences. Then we're going to square all those differences. Then we're going to add all those differences up. Okay, so that's what this just means, summation, add them all up. That's new. Last year we had a whole unit on what's called series and sequences, and we would have used that a whole bunch, but that's a new thing. So this just means add them all up, divide by the number of numbers in the data. So n is the number of data values in the set. That's variance, which is the same thing as sigma, which is standard deviation, this little sigma symbol. That's standard deviation squared. So when I square root all of that, I have my standard deviation. So let's go through that process here. So here's the original data. And if I want to type in my calculator, I want to add all these up and divide by 1, 2, 3, 4, 5. So x bar, if you add those up and divide by 5, you get 14. So the mean, that's step 1, find the mean. Step 1, find the mean. Step 2 is find the difference between every data value, so 9, 12, 14, 16, and 19. All 5 of those, I need to subtract 14 from them to find the difference. So I'll take 9 minus 14, 12 minus 14, 14 minus 14, 16 minus 14, and 19 minus 14. Okay? So I'm going to take all these differences then, I'm going to square them over here. So the difference here is 5. Even though it's negative, I'm going to square it, so the negative doesn't matter. So 5 squared is 25. The difference here is 2. 2 squared is 4. The difference here is 0. 0 squared is 0. Difference is 2. 2 squared is 4. Difference here is 5. I wrote it down. I don't know why I put, sorry about that. That should all be 14s. It's 5. 5 squared is 25. These are symmetrical. That's not always true. Okay, this example, I kind of made it easier. That's the data is symmetrical. 25, 25, 4, 4, 0. It's not going to happen like that. Add all these up now. So I did all the differences. Now, square them all. I did that. Now I need to find the average. Well, the average means add them all up, add up all the squared differences, and divide by the number of numbers. So I add up these squared differences, and I get 58, and it says divide by n. Well, that n is 5. Okay, so I'm going to divide by 58 divided by 5 is 11.6. So basically this is, on average, the distance from each data point from the mean squared is 11.6. So that's squared, that's variance. Now I want to square root that, so I'm going to square root 11.6. I get 3.41. So the whole point of squaring was to get rid of the negatives. So notice we squared here, and then later on we square rooted. Okay, so we're just trying to find the average difference, or average distance from the average, from the mean. So these data points, on average, they're about 3.41 units away from the average. Well, the average is 14. That's what standard deviation is all about. So the higher this number, that means on average, most of the data is further apart from the mean. And if it's a lower standard deviation, that means it's more packed in tightly. So let's say that my class average for the Unit 4 test, and this is totally made up, so this isn't, my class average for one class in Algebra 2 was 74 with a standard deviation of 6.54. The other class had an average of 70 and a standard deviation of 8.38. So which class, first off, which one did better? Well, this class did better, but which one had more variability, so less consistent data? So we'll say class 1, class 2, and I'll say X bar is the mean, and this is standard deviation. So one of them, class average is a 74 with a standard deviation of 6.54. The other one's a 70 with an 8.38. This one had a higher score, has a smaller number for standard deviation. But when we're talking about variability, if you want consistency, you want a smaller number. This one had more variability. On average, each piece of data was about 8.38 units away from 70. So it's more spread out. So when it says more variability, that'd be class 2 had a higher standard deviation. Okay, because this one is higher, it's bigger, things are spread out more. Okay, let's flip this over now. Luckily, because that process right there was for 5 pieces of data, and it took some time. You know, if we said do it by hand, it wouldn't be much fun, and you could do it. I mean, we could do it over and over and get really good at it. But we also want you to be able to use your calculator, because what if I gave you this much data? Okay, so the table below displays the number of U.S. hurricane strikes by decade from 1851 to 2000. What is the median standard deviation for this data? So it means during the first decade, so from 1851, I'm guessing to 1860, there were 19 hurricane strikes during that decade. In the second decade, there were 15. So really, I'm trying to find the mean and standard deviation of this data right here. These are just describing what they came from. Okay, so it would take a long time to have 15 pieces of data, because first I'd have to find the average. Then I'd have to subtract every one of these numbers from the average, 15 new numbers, square them, add them up, divide by 15, then square root. It takes a long time. But I can also do it on my calculator. So we're going to do a process we actually used earlier in the year. And I apologize, in the middle of that video, my microphone stopped working, so I had to split it into 2 videos. But anyways, what I was saying was, we did this process earlier in the year. We had to go to the lists and put the data in. Now we use it for finding a parabola through 3 points, but I'm going to do kind of the same thing. So first off, I need to push. I need to say this again because it didn't catch it. The microphone didn't work. But I need to push stat and then edit. And if there's already something in the list, you want to go up to where it says L1. Do not hit delete, hit clear. You want to hit clear and then enter, and it clears all the data out. Now I want to type in all of this data, so 19, 15, 20, 22. So I'm going to pause the video and do that. Okay, so while you're typing these in, notice at the bottom here it says L1, and the number in parentheses is which number you're typing in. So this would be the 15th number I typed in, and there's 15 numbers. That's one way to check. You do want to go back through and double check that I typed them all in right. You know, because if you type in one number in wrong, everything's wrong. So type in all that stuff, and then you want to go back to stats. I'm going to push the stat button. Now I want to calculate something. Okay. Now we just put in one variable. There's one variable here, how many hurricanes there were. Now there'd be a reason for 2 variable stats. If you're putting in 2 different variables, we're not doing that. You might do that in AP stats or stats and probability, but we don't do it here. So we're talking about the statistics for one variable. Frequency list, leave it blank for now. We're not going to mess those. If we ever do, I'll tell you. We'll practice it, but I don't foresee us doing that. And then hit calculate. So I'm going to find the one variable stats for L1. And notice that it matches this picture right here exactly. And on here are some symbols. So, by the way, all the steps I just did are right here. So if you need to go back later and you don't want to watch a video, they're all right there. So there's a lot of data, but you only want the indicated value. So the mean for this one is, I'll go over here even, say X bar is 17.6. And then the standard deviation Again, there's two numbers here. Now this SX does mean something. Again, we're not going to talk about it in this class, but it means something. You want that little sigma symbol, sigma X, that's the one you want. Okay, so 3.517, somewhere in there. Okay, so that's how you find the standard deviation with the calculator and not have to do all those steps we did on the front. Now, one thing we're going to look at here, let's plot this data. Let's plot this data on here onto, let's call it dot plot. And all you do is you can put dots or you can put X's or whatever symbol you want, but for every number up here, put one on down there where it corresponds. So for 19, I'm going to go to 19 and put an X. And then for 15, put an X. You want the first row to be here, second row, you want them all to line up. Okay, you don't want to squish some together, and they should be stacking up on each other, and we want to see which one's the tallest. So I'm going to pause the video. You go ahead and finish that. Finish putting them all in there, and then we'll talk about it. Okay, we got something like this, and again, try to make this is the first row, this is the second row. So, a lot of the data, there's, the stuff in the middle was more likely, the stuff on the ends was less likely, and eventually there were none of the extremes. Like 10 and 26 on this scale, there weren't any of those. So plot the data values below, then mark the mean and standard deviation boundaries. So my mean was at 17.6, which this is 15, 16, 17, a little over halfway. So about right there, I'll put X bar. There's my mean. Okay, there's my mean. And then I want to go up about 3.5 in each direction and down. So if I go up 3.5, so there's 1, 2, 3, and then 0.5 would be about right here. This is one standard deviation above. So we would say this is the mean plus a standard deviation. Then from there I go up about 3.5. So 1, 2, 3, and about a half, so about right here. So that would be the mean plus 2 of these standard deviation intervals. So there's 1, 2. Go the other way now. So 1, 2, 3.5 would be about somewhere in here. So that'd be the average minus a standard deviation. Okay, so we're going down one standard deviation from the average. From here I go down 1, 2, 3, and then about a half would be somewhere in here. We're just kind of estimating again. So this would be the mean minus 2 of these standard deviation intervals. Now notice all the data is between two standard deviations, above and below. Okay, so we would say that all the data, maybe I'll pause and write this so you don't have to watch me write. We'd say that all the data is within two standard deviations of the mean. So within two, so give or take two standard deviations, all the data collects that. And that is true most of the time. So if we continue, again, I'm going to pause the video so you don't have to watch me write. So if we continue to collect data, so if we went back even further, if we could, maybe data wasn't collected before 1851, but if we just kept going back and back and back and back and collecting more data, 95% of the decades total would fall between these two numbers, which is about 10.5 to 24.5 or so, somewhere in there. So it's pretty. So 95% of the time you'll have between 10.5 and 24.5 hurricanes coming in. That's just a general rule in statistics. The data needs to be what's called normal. We're not going to get into that. Most things are normal. A lot of things are normal, a lot more than you would think. Like if you did heights of adults, in America, you could do this. It's a very normal distribution, which means around the average height, you're going to have a ton of people, and then it just drops off slowly to the edges where you have very few people that are, say 7'2". You have very few people that are under, whatever height that would fall in. So you just, as you get further away from the mean, the probability of being that height's much lower. But 95% of the time, you'll be within two standard deviations, above or below. So even though this is a span of 4 standard deviations, we say it's within 2. Because here's a mean, so you're 2 up or 2 down. You're within 2 standard deviations of it. The example here, it says, use the standard deviation for each year to describe how farm income varied from 2001 to 2002. So here's farm income, millions of dollars, so in Iowa and Kansas and so on. Now, describe how it varied. So, variation, we want to look at, how big the standard deviation was, how big sigma was. So get out your calculator and type these numbers in. We'll put this in L1 and put this one in L2. Okay, so push stats. edit, and then for L1, I can just type over it, or if I want to clear the whole data, again, hit clear and enter. Don't hit delete. It's a problem. If you do that, tell me, I'll come help you fix it. So 10,653, I'm going to type this in L1, and then 10,834, I'm going to type all this data in L2. Okay, so I'm going to pause the video, I'm going to type it in. Okay, so I typed it in there, and then I'm going to go to Stat, over to Calc. Again, I need to do these one at a time, so I'm going to do 2001 was an L1, so I can calculate that first. So the standard deviation was 2678. Or I could do the average and the standard deviation here. So the average was 6706, we'll say 0.9, and the standard deviation was 2678.9. Now I'm going to do 2002, which means I got to change the info a little bit. I'm going to Stat over to Calc, one variable stats, but I need to change that to L2. So if you remember, the quickest way, if you look above the number 1 is L1, above the 2 is L2 and L3. I want L2, so I'm going to push second, and then that button, it changes it to L2 for me. Okay, go down to calculate. So the average this year and the standard deviation this year was 6738.1, and then standard deviation was 2758. Well, we'll say 59.0, because that's pretty close. Okay, so the averages weren't too far off. In 2022, it went up a little bit, but the standard deviations changed quite a bit there, so about 100 more. And maybe not quite 100, but it went up a little bit. So slightly more variation. In 2002. Let me say it right. And then for 2001, the farmer incomes for which state are not within one standard deviation. So if I want to go within one, I'm going to take this number plus or minus this number. Okay, so let's take that number, so 6706.9 plus 2678.9. And I'm just going to go copy it and change that to a minus. So I'm going to find between 4028 and 9385.8. So which one of these are not in that interval? So which one of these are not? And it looks like, let's see, Iowa's not. Iowa, let's see that. So this one's not, this one is, this one is. Ooh, that one just barely made it. That one barely made it. That's too low. So North Dakota and then South Dakota. South Dakota. So now that's within one standard deviation. So being outside of one doesn't make it terribly, terribly rare. But if you're more than 2 standard deviations away, you're in like the outside 5%, basically, because 95% fall within 2. Yeah, so if you're wondering, it's actually 68% fall within 1. Okay, so 68% fall within 1, 95 fall within 2, and actually 99.7% fall within 3. So if you're beyond 3 standard deviations, you're a very rare case.